Alrighty, so with this video, we're going to talk about a pretty important topic that's kind of wide-ranging, not just with physics, but all of the sciences, and that is dimensional analysis. Now, it sounds like a fancy term, dimensional analysis, but all it really means is we're going to discuss units. So, of course, to get started, we need to understand why in the world this is even an important topic to discuss. Why do we care about units? Not just why will they be useful, but actually critical in any time we're going to be talking about various things we observe in the real world, various things we want to measure. Why are units so important? And the easiest way to think about it is, what if I asked, for instance, what is the temperature outside? Nice basic question. And let's say someone said it is 10 degrees even. 10 degrees, okay, well, this gives some information, but it really doesn't give all that much information because, for instance, let's say you're a gardener. Maybe you're growing tomatoes and cucumbers and different vegetables in the garden, and you might want to know what the temperature outside is going to be because, of course, with things like tomatoes and cucumbers, if it freezes outside, if the temperature gets below freezing, it actually kills the plants. And so usually gardeners, if they know there's a chance that it'll freeze overnight, they'll do things to try to help prevent the plants from dying. They'll put, sheets and plastic over to try to keep the warmth in. Or if they're in pots, they'll bring them inside, indoors. And the reason I'm saying this is because 10 degrees, well, if it's 10 degrees Fahrenheit, that's freezing. Because, of course, in the United States, we use the Fahrenheit as our unit of temperature. And 32 degrees is freezing. Anything below 32 degrees is considered freezing temperatures because water freezes at 32 degrees Fahrenheit. But 10 degrees Celsius is not freezing. So if I were a gardener and someone says it's going to be 10 degrees and I'm in England, well, I'm not worried about it. 10 degrees, that's fine. It's cold, but my plants will survive. But in the United States, if someone says it's 10 degrees, then I'm going to worry about it because my tomato plants are going to die. So just giving an answer, even if the answer is correct, doesn't really provide all that much useful information, especially if we start considering that, we have the universe to consider. It's not just here in this country or that country on the earth, but if we're trying to discover the laws of nature, the laws of the universe, the physical laws, that way maybe we could predict what will happen in the future, or we can explain what it is we see in the real world. Well, our own human things like 1 second or 1 pound or things like this, they're kind of immaterial. They're not universal. They have to do with we as a society, as a culture, as a civilization, and how we describe our answers. But if we were to meet aliens and we were to tell the aliens, hey, I could lift 150 pounds, they have no idea what the heck that means. What the heck is a pound to an alien? Much less to someone in Europe or anything else where they're not using pounds in the imperial system. So units are very important. If I say, how long is it going to take? And I say 2, well, is that 2 seconds, 2 minutes, 2 hours, 2 years? What do we mean when we say the answer is 2? And that's where units come into play. So the first thing I need to tell you is that if you're doing science, for the most part, you're probably going to be using the metric system. And there's different metric systems. There's different systems of measure. However, what usually defines the metric system is the fact that the units that we're going to use are all coming in powers of 10. So for instance, let's say the unit of length. If we want to talk about how long or how far or the distance or whatever, a unit of length in a metric system uses meters. The meter. Okay, 1 meter. Here in the United States, we don't use the meter. We use feet and inches and things like this. But for a rough estimate, 1 meter is like 1 yard. So about 3 feet. Not exactly. There's a specific conversion factor, but for instance, it's a meter. Now, this powers of 10 thing I was talking about goes to the fact that, of course, 1 meter is a pretty big length. If we're talking about the size of a human hair or, the thickness of a pencil, we won't do it in meters. So you do it in some other units that are related, like centimeters or millimeters or things like this. Or maybe we're talking about long distances, then we're talking about kilometers. So we have things like subdivisions of this standard unit of length, like the centimeter or the millimeter or the kilometer and things like that. And what makes these, what separate the different kind of measures is that, for instance, 1 meter is 100 centimeters. So powers of 10, 1 meter is 1,000 millimeters, and so on. So these other units, the centimeter, the kilometer, things like that, they're all related to the base unit of the meter by dividing or multiplying by powers of 10. So for instance, 1 kilometer is 1,000 meters. And the same is true for most of the units in the metric system. For instance, another unit that's important is the unit of mass. So it turns out in physics, we don't really care about weight, how heavy something is or things like that. And the reason we don't is because we like things in physics to be fairly universal. And an object's weight depends on where it is you're measuring. Are you measuring here on Earth? Then it's got a particular weight because the weight depends on how strong gravity is. But if you're on the moon, that same object will have a completely different weight. So weight is kind of a squishy thing. It's useful to use here on Earth, but when we start talking about universal laws, weight doesn't matter, it's mass. Mass is that universal thing. Something that has a particular mass here on Earth will have that same mass no matter where in the universe you're measuring. And the unit for mass is what's called the kilogram. It's kind of weird because, for instance, with the meter, the unit is the meter, and we have kilometer, kilometer. Well, for mass, the base unit is, of course, the gram, but in physics we use kilograms. So the gram is the base unit for mass, just like the meter is the base unit for length. And then you have other things like centimeter, millimeter, kilometer. Same with mass. You have gram, you'd have milligrams, centigrams, you'd have kilograms, all sorts. So with these units, the ones we're going to concentrate on for physics are going to be the top 3, the main 3 units. And it turns out most of the stuff we talk about in physics are going to be comprised of a combination of these 3 units. The first is length, and we already covered that. The length, the unit is called the meter. M is the unit, little m. Then there's mass, and gram is the base unit. That's little g. But like I said, for physics, we use kilograms as the base unit. If I'm in chemistry, for instance, they use the gram as the base unit. If I'm in astrophysics, I'm probably not using kilograms. I'm using, the mass of the sun as a unit, something like this. And the last one is time, the unit of time, which is the second. Of course, little s. And so with these three units of measure, the length, the mass, and time, we can comprise all sorts of other things. Things like force. I can apply a force to an object. What is the unit of force? That's called the Newton. Of course, here in the United States, it's the pound. But in physics, the metric system, it's the Newton, which is capital N. And it turns out that the way you get this unit of force called the Newton is by combining the other units together in a particular way. And it turns out that if you combine the kilogram times the meter divided by seconds squared, if you get that combination of units, we call that combination the Newton. And we just don't feel like writing kilograms, meters per second squared every time, so we give it a different name. We call it the Newton. Energy, that's another one. The unit of energy in physics in the metric system we use is called the joule. Okay, its unit, of course, is capital J. Again, that's a combination of these three main units. It's not its own thing. It's the combination kilograms, meters squared per second squared. So if you combine those three units together in that particular way, that's called the unit of energy. How much energy are you using? How much energy are you giving the system? Whatever it might be. Now, there are other things which have their own units that are not a combination of these things. For instance, I'll just give you an example. In electricity, we have the unit of charge. The charge has the unit called coulomb. Capital C. There's no way to get the unit of coulomb from these three units, mass, length, and time. It's its own thing. So, okay, there are some things out there that have their own special unit, but 90% of the things we talk about in physics will be some combination of these three units here. The length, mass, and time, or in other words, meters, kilograms, and seconds. Again, the actual base unit is grams, but in physics we use kilograms as our base unit. All right, now just to give you some info, of course, here in the United States, we don't use those three units. I mean, we use one of them. For us, we use feet or inches for length. Of course, we still use seconds for time. We use the pound or lb for force, all this kind of stuff. So the imperial system, which is what the United States uses, if you're an engineer, for instance, you have your own imperial units that you use, but most everywhere else in the world, they use the metric system. Not everybody. For instance, there's a lot of European countries that kind of have a combination. In Britain, for instance, most things are in kilometers, but their street signs are still in miles per hour, things like kilometers per hour, but it'll tell you it's 5 miles away. Or fuel, 5 miles to the gallon. Well, of course, in Europe, they use liters and things like that, and kilometers. But there are still times where they use some of those old imperial units. Or you ask somebody how tall they are in Britain, they're going to tell you, 6'1". Even though they don't use feet as their normal unit, they use centimeters and meters. It's just a holdover from that's the units they used to use, and it's still hard to get out of it. The United States, of course, we're the imperial system, and that's going to stay that way. But when you're doing science, it's useful to use the metric system purely because the numbers are easier. Multiplying and dividing by powers of 10 is easier to do than multiplying and dividing by powers of 12 or other things. 12 inches in a foot or 5,280 feet in a mile. We got some weird numbers out there. And if you're used to it, it's no big deal. Obviously, having things that are powers of 10 is just nicer in terms of the math. So that's what we use, the metric system. All right, so what do we actually want to do with these units? Well, the first thing is we need to know how to convert. How do we go from, for instance, let's say I tell you something is 5 meters long, and I want to know how many centimeters is that. So I'd give you, let's say, a plank of wood, and that plank of wood is 5 meters long. And I say, tell me how many centimeters that is. How do you do something like this? Well, most of us have already seen how to do this before, but if you haven't, I'll show you, of course. But also, you may have seen it done slightly different or a different way of thinking about it. I'm going to show you the way I think about it, which is the most baby way possible, like I'm a kindergartner, just because it's very, very easy sometimes to confuse when you're doing conversion. Should I multiply by 100 or divide by 100 or whatever it might be? So I'll show you a foolproof way. You will always do it right. You'll never divide when you were supposed to multiply or whatever. You're going to have to know a few things. First thing we need to know is, how does this system work? So let's say we have the base unit. Base unit goes here in the center. Now what I'm going to do is I'm going to write other units, like so for instance the base unit is the meter. Now what I'm going to do is to the right I'm going to write units that are smaller than a meter. So like a centimeter or a millimeter. Those are smaller than the meter. So we have deci, centi, milli. So a millimeter is like mm, millimeter. M for milli, M for meter. cm is like centimeter, and so forth. So we have deci, centi, milli. Then there are more. Of course, we usually ignore the next two because they're not useful very often. There's two more. I won't even tell you what their names are. Then there's one called micro. That's the Greek letter mu. Mu. And it stands for micro. So a micrometer or a micrometer. Then there's two more. Then there's nano. And then two more. Pico. And you could go on infinitely. Smaller and smaller powers of 10. Okay, so how do you go this way? If I say I've got 5 meters, so I have 5 of the base unit, and I want to know how many centimeters it is, well, I'm going from the base, I'm going to go 1, 2 to the right, so that's like multiplying by 10 squared. Okay, each time I go 1 to the right, I'm multiplying by another power of 10. So in other words, multiplying by 10 squared is like saying multiplying by 100. So for this particular example, 5 meters, how many centimeters is that? Well, that's 5 times 10 to the 2, or 500 centimeters. Okay. If, for instance, I said I have 3 meters, and I want to know how many micrometers that is, well, I would say, okay, let's go from the base unit. We're going 1, 2, 3, 4, 5, 6. So that's times 10 to the 6th. So 3 times 10 to the 6th micrometers. Or if we want to write it out, 3 with 6 zeros. 1, 2, 3, 4, 5, 6. Okay, that's how you go to the right. If you're given the base unit and you want to get one of the other units, going to the right, you're multiplying by powers of 10. Here's another example. Let's say I said we have 50 millimeters, and I want to know how many nanometers that is. Well, let's see. We're starting on milli, and we're going to go 1, 2, 3, 4, 5, 6. So it's going to be 50 times 10 to the 6th nanometers is 50 millimeters. Okay, so pretty easy. If you either have in your mind this little layout of the units, or you write it down on your paper until you're comfortable with it, and then you literally just count the number of spaces, and that tells you how many factors of 10 you're going to multiply by. But of course, what if we want to go the other way? Let's say I said we have 5,000 meters, and I want to know how many kilometers is that. Okay, well, I've shown you going to the right. The same thing happens to the left. You start with your base unit. And now we're going to go to the left, but going to the left means we're getting bigger and bigger units. Okay, just like going to the right made the units smaller, going to the left makes them bigger. So what do we have? We're going to skip the first two because they're almost never used. So blank, blank, and then we have kilometers, or kilo. Okay, so if the base unit is meters, then we go to the left 3 times, that's kilometers, kilometers. Okay, or if we're talking about computers and space and data, memory, how many bytes of information? Well, that would be, 10 kilobytes. 1 byte is the base unit. Kilobytes is thousands of bytes, or times 10 to the 3, as we'll see. But then we keep going. We skip 2 more, and then we get mega. That's a capital M. Remember over here with the going smaller, these are all lower cases. Little d, little c, little m. Little k for kilometer, but M, this M is the capital M for mega. Mega. So like megabytes in computers. And then again, we skip 2. And what comes after megabytes? Of course, it's gigabytes. G for giga. Again, skip 2. Capital T for tera. And so forth. Okay, again, you could continue going infinitely to the left, just like you could with the right. So, let's say I want to answer a question like this: how many kilometers is 5,000 meters? We do exactly the same as we did the other way. We're going to count how many times we have to move to the left, and that'll tell us how many factors of 10 we have to divide by. Okay, so for this particular example, 5,000 meters, so we're starting on meters. To get to kilometers, we go 1, 2, 3. So that means we're going to multiply by 10 to the minus 3. Okay. So this is 5,000 times 10 to the minus 3, which if you stick that in your calculator is 5. So 5,000 meters, how many kilometers in that? That's 5 kilometers. Okay. Or another example, let's say I have 120 megabytes, and I want to know how many gigabytes is that. Well, again, we do exactly the same thing. We're starting on mega, so here we are at mega, and now we have to get to giga, so we're going to go to the left, 1, 2, 3. So again, times 10 to the minus 3, or dividing by 1,000. So it's 120 times 10 to the minus 3 gigabytes. or in other words, 0.12. Okay? And of course, we could combine everything, right? You could take the full length, so here's the base unit, and we have deci, centi, milli, blank, blank, micro, blank, blank, nano, blank, blank, pico. And then to the left, we have blank, blank, kilo, blank, blank, mega, blank, blank, giga, blank, blank, tera, and so forth. And now, no matter what I give you, so let's say I say we have 102 megabytes, and I want to know how many millibytes that is. How do I do it? Well, I start on mega, here's mega, and I'm going to count how many times, how many spaces I have to move to get to milli. If I move to the right, I'm multiplying by 10 to the positive number. If I'm moving to the left, it's 10 to the negative number. So I'm moving to the right, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 102 times 10 to the positive 9. Okay. If I move to the left, so let's say I start at nano and I want to get to kilo, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's times 10 to the minus 12. If you move to the left, you get 10 to the minus numbers. If you move to the right, you get 10 to the positive numbers. Okay? That's how we can convert normal base units. There's another type of conversion, however. The other type of conversion is when you have two different types of units. So let's say, for instance, I want to convert meters to feet. So I'm going from from the metric system, and I want to go into the imperial system. Or vice versa. Maybe I want to go from pounds to kilograms, or that's hard to do. Or Celsius to Fahrenheit, right? I'm changing the units. I'm going to something else. I'm not just getting smaller or larger versions of the units. Centimeter is just the meter, but smaller. I'm going to a completely different system. How do I do something like this? So I'll give you an example. Let's say we have 8 meters is how many feet? Nice classic example. How do we do this kind of conversion? This one's a little bit more difficult because it's not just about multiplying by powers of 10. You have to know something about the units. How do they relate to each other? How do I get from meters into feet? I'm not just dividing by 100. So you have to have some extra piece of information. So the extra piece of information I happen to know off the top of my head is that in 1 inch, there's 2.54 centimeters. Okay, that's a conversion for whatever reason. When I was really young, they taught us this in school, and it's stuck with me ever since. There are other conversions to go directly from feet to meters. I just don't know what it is off the top of my head, and I'm too lazy to go Google it. If you know the conversion, then you could use it immediately. If not, like me, I know this conversion. It's going to take me a couple more steps, but I can still do it, and I'll show you how. So first, before we do the big one, I want to talk about this conversion. Let's do an example with just that. Let's say we have 7 inches is how many centimeters? Okay, how would I do this conversion? Well, the way I do it, I'm going to set it up like a math problem, because it turns out if we could set things up like math problems, that's very powerful, and it allows us to solve things very, very easily, because all you have to do is follow the rules of math. You don't need some mysterious information or super skills or whatever to be able to do it. No, if you could set up the equation, then you just follow the rules and you get the answer. It's like a machine. So here's what I'm going to do. I'm going to multiply stuff together, little fractions, and get what it is I'm trying to get at the end. So here's what I'm going to do. I'm going to start with what I know. What I know is I'm starting with 7 inches. Okay, and I'll divide that by 1, so it's 7, right? 7 over 1 is just 7. Now I'm going to multiply by something. But what do I multiply by? Well, it's going to make use of this conversion I talked about here, but I have to put it in a certain way. I'm going to have 1 inch on one of the lines, either top or bottom, and 2.54 centimeters on the other. So which one goes in the numerator, which one goes in the denominator? This is what I was talking about earlier, why I do it the baby way, because it is easy to forget, especially if you have a complicated conversion. Should I be dividing by 2.54 or multiplying by 2.54? So here's the trick. The trick is, if I'm trying to get 2 centimeters, then I have to get away from the inches. So in order to get rid of these inches as a unit, I need to put the units downstairs in this fraction. That way they cancel. Right? If you remember your fractions, 3 over 5 times 2 over 3, something like this, the 3's cancel, and you're left with 2 over 5. If you remember that kind of math. Well, same thing with the units. The units can cancel too. So if you have 1 unit in the numerator, the same unit in the denominator, they cancel out. And so if the inches go on the bottom, 1 inch is 2.54 centimeters. Goes on top. Because you already used the bottom. You used it to cancel the other guy. And so now, if we were to multiply these 2 fractions together, what would I get? Well, this inches cancel out. I've got centimeters over here in the top. And then in the bottom, 1 has nothing. And these inches over here is nothing. So nothing on the bottom. So whatever answer I get, if I multiply these 2 numbers together, will give me units of centimeters. And that's exactly what I'm trying to get to. So now I just follow the math. There it is. Here's my equation. 7 times 2.54 tells me 17.78 centimeters. And that's the answer. Okay? So that's all there is to it. We're going to be taking a series of fractions. We're going to be putting something in the numerator, something in the denominator, based on a particular conversion factor we happen to know. And we choose which one's in the numerator, which one's in the denominator, in order to cancel out the bad units and keep the good ones. And then once we've done all of that, we now have one big long equation. We just plug all this stuff in our calculator and we get an answer. So let's do another example, a simple one like this, and then we'll do the big one, this black one that I mentioned right there. So another example, let's say we have 15 centimeters, and I want to know how many inches is that. Well, we do the same starting point. We have 15 centimeters over 1, and now we're going to multiply by something. Again, remember, what I know is that in 1 inch, there's 2.54 centimeters. So what is it I'm trying? I'm trying to get inches, but I want to get rid of the centimeters. So centimeters has to go on the bottom here to cancel those centimeters. Once I know that, then it must be the top that has inches, right? And what do I put as the numbers? Well, for centimeters, it's 2.54. And for the inches, it's 1. So if I were to multiply this out, what happens? The centimeters has canceled out, and I'm left with inches as my answer, which is exactly what I want. And so now I just literally multiply the 15 times 1 over 2.54, or in other words, 15 divided by 2.54, and we get 5.91 inches. So that's how we convert, right? This is a one-step conversion. I know a conversion factor. That's going to tell me what goes into this fraction here. But which one goes on top, which one goes on bottom, depends on what your final answer wants to be. If you're trying to cancel out the centimeters, then you have to put it, if the centimeter starts up top, you got to put it on the bottom over here so they cancel. And then once you know that, the other thing has to go on top. Okay? All right, so now let's do this example, this 8 meters to how many feet? Example. I have 8 meters, and I want to know how many feet is this. All right, well, this is going to be a little bit more complex, but it's the same basic process, just with a couple more steps. That's why I like this method. I don't have to think at all. It just gives it to me, and then I physically put it in my calculator. So again, what do I know? All I know is that in 1 inch, there's 2.54 centimeters. Of course, I also know that in 1 foot, that's 12 inches, right? That's something we know here in the United States. And of course, with the meters, if you remember, 1 meter was 100 centimeters, or 1 times 10 to the 2 centimeters, 100. All right, so how am I going to get from meters to feet? Okay, well, let's start with the meters. We have to start at the beginning. So 8 meters over 1. Now I have to multiply by something. Now the thing I want to multiply by, I have to get rid of these meters. The meters are bad units. I don't want them in the end. So whatever I'm going to multiply by, I know meters has to go on the bottom over here to cancel. And eventually I want to get to feet. But the only way to get to feet is through inches. And inches I get from centimeters, right? If I can get from centimeters to inches, well, then I just have 12 inches in a foot and I'm done. The problem is I don't have centimeters, I have meters. So to me, the first thing I should do is use the fact that I know 1 meter is 100 centimeters. Right? So if all I did was this one conversion, that would tell me how many meters are in a centimeter. I'm sorry, how many centimeters are in 8 meters, right? I'd get 800 centimeters is 8 meters. But that's not what I want. That's only part of it. I've now gotten to centimeters, okay? Well, that's not the end, so I again have to multiply by something, another fraction. What do I know? I want to get rid of these centimeters. I don't want centimeters, I want feet. So let me put centimeters on the bottom to cancel these centimeters. Now, what conversion do I know to get away from centimeters? Well, I know that there's 2.54 centimeters in 1 inch. And so now, if I multiply all of this stuff together, I'll get there's this many inches in 8 meters. Okay, so I'm getting closer, but I'm still not at feet. I'm at inches. So I got to do another step. Multiply by another fraction. I want to get rid of these inches, so inches is going to go on the bottom. And the conversion I know is that there's 12 inches in 1 foot. And so what would happen if I were to multiply all of this stuff? Well, the meters have canceled, the centimeters have canceled, the inches have canceled. I'm left with feet. So my final answer is going to be some number of feet. And now I just follow these rules to tell me how to get to feet. I multiply by 8 by 100, then divide by 2.54, then divide by 12, and that'll tell me how many feet. So 8 times 100. Divide by 2.54, I get an answer. And then I divide that answer by 12, and I'm told there's 26.25 feet in 8 meters. Okay, does that make sense? Remember earlier I said a meter is about a yard, which is about 3 feet. So if it was exactly 3 feet, I would expect 24 feet is 8 meters, right? 8 times 3 is 24. But it's a little bit more than 24. It's 26 because, of course, it's not exactly 3 feet in a meter. It's approximate. It's close. The actual answer is this 26.25. So notice if I didn't do this whole this whole string, all these little baby steps, would you have been able to tell that you divide by the 2.54 and you divide by the 12 instead of multiplying by 12? I don't think I would have been able to. Now, of course, if you happen to know a straight conversion that goes from meters to feet, for instance, it turns out, if you look it up, that there's 3.28, about 3.28 feet in 1 meter. So I could just say 8 times 3.28, and that would give me the answer directly. But I don't remember this. What I remember, like I said, for whatever reason, is inches to centimeters. So I have to go through all these little bitty steps to get from meters to centimeters, centimeters to inches, and then inches to feet. But that's okay. I take an extra minute to do the calculation. But the good thing about this version is that I don't have to consider should I multiply or divide. The math does it. If I want to cancel the unit, it must go here. And once I know it goes there, the other thing goes at the top or the other thing goes at the bottom. Okay. One more example I want to show you is the most complicated, and that's if we have something like 100, let's say, miles per hour, and I want to know how many kilometers per second, sorry, not kilometers, how many meters per second is this? Okay, so this is a pretty complicated conversion. They're both speeds. How fast are you going? Certain number of miles per hour versus certain number of meters per second or centimeters per second or kilometers per hour, whatever you want. In this case, this is a conversion I want. How do I do this? Well, we do it exactly the same way we did the other one. There's no difference. Let me write down the things I know. I know that 1 inch is 2.54 centimeters. I know that 1 mile is 5,280 feet. What else do I know? I know that there's 60 seconds in 1 minute and 60 minutes in 1 hour. These are things I know. Once I have that, now let's go ahead and do the conversion. So we start with what we start with, 100 miles over hours. And now I'm going to multiply by a fraction. Now what I'm trying to get to is meters divided by seconds. Well, both of my units are bad here. Miles, I don't want miles, I want meters. And hours is bad, I want seconds. So I'm going to have to convert both of those units by the end of the day. But I'm not going to do them both at the same time. I'm going to do them one at a time. So let me work on miles first. First thing I'm going to do is try to get away from miles and into meters. So if I want to get away from miles, well, miles goes on the bottom, so that cancels that miles. And what do I know? From right here, 1 mile is 5,280 feet. So 1 mile is 5,280 feet. Then I'm going to multiply by something to get away from the feet. I don't like the feet there, so they go away. And what do I know about the feet? Well, I know that in 1 foot, there's 12 inches. All right, now what? Well, again, I don't want inches, so I'm going to get out of the inches. Inches go on bottom to cancel. And I know that in 1 inch, there's 2.54 centimeters. And then lastly, I want to get out of centimeters, so they cancel. And I know that there's 100 centimeters in 1 meter. All right, so notice what I've done. If I were to multiply all of this stuff, the miles cancel, feet cancel, inch cancel, centimeters cancel, and I'm left with meters. But on the bottom, I still have these hours sitting here, right? So the answer, if I just did this, would be meters per hour. But that's not what I want. I want meters per second. So I took care of the miles. The miles is now in meters. Perfect. I don't do anything else with him. Now I continue multiplying, and now what I want to do is get rid of these hours and make them seconds. So what can I do? Well, now notice hours is in the bottom. So if I want to cancel the hours that are in the bottom, I got to put hours up top. So now that hour cancels that hour. And what do I know? 1 hour is 60 minutes. But now minutes is bad, so I can multiply again. Because minutes is in the bottom, I got to put minutes up top again. And I know that 1 minute is 60 seconds. And so now, if I were to multiply all of this stuff, what would my final answer units be? Well, everything cancel, everything cancel. I've got meters and I've got seconds. So whatever the answer is, it's going to be meters per second, which is good. But now I just need the number. So now I get my calculator, and I'm bad with the calculator, even though I'm a physicist. So I do this step by step. So I go 100 times 5280 and equals, and I get a number. Then I multiply that number by 12, and I get a number. Then I multiply that number by 2.54 equals, get a number. Right now, I'm at this point right here, and I'm at 16,093,440, if you're doing this along with me. But then the next step is divide by 100. So I divide by 100, get a number. Then I have to divide by 60. So divide by 60, get a number. Then I have to divide by 60 again, and I get a number. And I get the final answer is 44.7 meters per second. So 100 miles per hour is equal to 44.7, about 44.7 meters per second. And notice how complicated this conversion is. Look how many steps there are. I had to get out of miles. From miles I went to feet. Feet I went to inches. Inches I went to centimeters. Centimeters I went to meters. Hours went to minutes. Minutes went to seconds. But at no point did I have to think about, should I be multiplying by the 12 or dividing by 5280? No. The unit cancellation process, the steps, told me which goes up, what go down. All I had to do was make sure that at each step I'm canceling the units correctly. And then once that's done, it's just a matter of feeding all these numbers into your calculator. Very, very powerful technique. No thoughts needed. However, it's tedious. Notice how many steps this took. If I were really good, I had a really good memory, then maybe I would happen to know that there's a particular conversion to go from miles to hour to meters per second in one step. I just multiply by this very special number. Just like if I want to go from inches to feet, or feet to inches, I'll multiply by 12. Right? If I've got 3 feet, that's 12 times 3 inches. Same way here. If I want to go from miles per hour to meters per second, there's some special number which does it for me. And I just multiply by that special number and I know it. But I don't know that number. It exists. You just go on Google, say miles per hour to meters per second, and it'll give you the number. But because I don't like memorizing stuff, I like doing it. That way, let's say you're walking down Bourbon Street at night, you go down a dark alley and 2 guys jump you, and they say, how many meters per second are there in 100 miles per hour? And you don't have your calculator, you don't have pen and paper, you don't have Google, you don't have your phone, and you have to do this. This is an easy way to do it without having to remember very specific facts. You just remember the basics that most of us know just from life. Yeah, 5280 feet in a mile is kind of a weird number, but you've lived in the United States long enough where you kind of remember it. Or 12 inches in a foot, you remember that. I don't remember, for instance, this one over here, that there's 3.28 feet in a meter. I don't know that, even though it's true. So no matter what kind of conversion you have to do, as long as you know the conversion factors, these little conversion factors up here like this, then being able to do even the most complicated conversion is pretty easy. You just have to follow these steps one at a time. Cancel this unit to get to the next one. Then cancel that one to get to the next one, until at the end of the day you're left with the unit you want. All right, so I hope this has been helpful. I hope this is understandable. Of course, if you have any questions, you're free to email me. But I'll see you next time.